Welcome and hello. This is a video exercise in HEC ResSim. And in this exercise, we're going to be discussing release rule prioritization. What I have on the screen here is the ResSim. It's a brand new watershed, and we're going to do this one step at a time to describe release rule prioritization. First, I'm going to select the watershed setup module and then click File, New Watershed. I'm going to give the watershed a name, video 12 for exercise 12, and then select the directory you want the watershed directory to be created in, and then select the time zone and the units, apply OK, and we are rolling. Okay, we have a watershed up on the screen here. I'm going to take you through step by step on building the network first before we get to the rules and how the priorities work. So let me zoom in a little bit and then pan over. I'm gonna first select this stream alignment tool and then hold down Control and then start left clicking to make vertex points and then let go of Control. And my final click will now prompt me for my the stream alignment name. I'll just call it Stream 1. All right, I'm going to add a computation point and then hold down Control, single left click on the stream alignment. I'll call it CP1. And then let's add a reservoir. This is the setup that I typically do. Reservoir 1 is fine. And then computation point at the bottom, hold down Control and single left click. Call that CP4. Yeah, when adding the reservoir, you need to click the reservoir tool and then hold down Control on the upstream, and then click on the upstream point first, and then drag it down. And yeah, the lessons go ahead and talk about how all the watershed editing features in ResSim. All right, let's click Watershed and Configuration Editor. This is gonna build us a configuration. I'm just going to call it config1. Okay, apply. And then let me save this watershed and then head over to the reservoir network module. And the first thing we need to do is create a network. So I'll just call it network 1. And then it'll be based on that configuration 1 that we just created and saved. And then we'll click new. Okay, let's click the reach tool here and then hold down Control, single left click on the upstream junction, and then drag down to the next downstream junction, let go Control, single left click, and then we can just accept that reach name that it suggests. Do the same thing for the reach that's downstream of the reservoir, and our network is connected. I'm going to give it a save, then we can zoom in a little bit here. Okay, first thing I want to do is create an inflow at my upstream reservoir, and I'm going to make it a constant inflow of 1000 CFS. And then I'm going to come down to the reservoir and edit the reservoir properties, including adding zones and rules. And then we'll start running some simulations and see how the priorities of those rules affect the operation. All right, so one thing at a time here. Let's right click on junction and edit junction properties. And then I'm going to add local inflow here. So I'm just going to call it something generic that's easy to identify and remember. Inflow at CP1, a factor of 1, apply, and OK. So we actually need to create a time series data set to represent those flows. All we've done right now is identify this junction as having inflows. So the alternative editor will expect us to assign a time series. I'm going to go ahead and open up DSS view from the tools menu. And then I'm going to, let's go create a DSS file. The default location is our watershed directory, so that's fine. I'll call it time series data.dss. Okay, the file's been created. Now I'm going to come up here and do data entry manual time series. There's other ways to create data, but this one's so simple. Let's just do it manually here. And for the file name parts, let me just type in some generic terms here. Part A is for the project or the location or the river or the watershed basin area. I'm just going to call it project. B is the location. I'm going to be very generic. And then I'm just going to call this a constant 1000 CFS inflow. All right, the date, let's do this for this simulation for the month of March 2024. So I'm going to just start on the beginning of the month, and it's going to start on the first hour. The units of flow is CFS, and then instantaneous value is going to work for me there. Okay, so automatic generation allows me to just fill out all the values automatically with whichever fill value I select here. So I'm going to type in 1,000, and then the last hour of the month would be March, and the time would be the 2400 hour mark. Okay, so if I tab off of that, I can click the generate button, and it gives me all my values. It's just the constant 1000 CFS here. All right, so I'm going to click save, and then no, I can check the plot to make sure it's what I want. And sure enough, we have a constant 1000 CFS. All right, so I'm going to close DSS for now and head over to the reservoir editor. I'm going to click the reservoir tool, right click on my reservoir one, and edit reservoir properties. All right, I like to rename the dam as dam. I'm going to define the reservoir geometry here by clicking on pool. Okay, now I'm going to paste in the geometry, which I had copied onto my clipboard just from an Excel file. So the base elevation is 1350, and the top of the top elevation is 1500. That's the top of the dam. So if I come over to the dam, I can just type in 1500 here. I'll just make up a length. And now it's time to add some outlets. I'm only going to have one outlet for this exercise because that's enough. Okay, I'm pasting in some numbers here. So this shows that the invert's 1400 because the flow's 0, but then at the max elevation, we have a max release capacity of 3850 CFS. Okay, we'll keep it at just one gate. And what I'm going to use in my zones, which I'm about to create, is a guide curve elevation of constant 1480. So I just wanted to point this out before we leave the screen that the max release at that elevation is 3640 CFS. Okay, so I'm going to click apply. I'll leave all the other settings as default and then head over to the operations tab. I'm going to go operations new. This is how I create an operation set. We'll call it operation set 1. Okay. And the 3 default zones of flood control, conservation, and inactive are fine. So I'll just keep those names as they are. And then I'm going to type in the top elevation of each zone. And it's going to start on January 1st. And if I click apply, that'll just be the value for the entire year. So that's what I want. Conservation, I'm going to start at 1480, apply, and inactive will, top of the inactive zone will be 1350, apply. Okay, so conservation here, this label in the zone rules tree is bold. And what that means is it's identified as the guide curve. So the reservoir is going to try to get its the water in the reservoir to 1480 on January 1st and, well, really the entire year. All right, let's go ahead and create a couple rules here. I'm going to right click on the zone and then add new rule. Okay, the first rule I'm going to add is a minimum release rule of 800 CFS. This is going to apply to the controlled outlet. It's a release function rule. So let me go ahead and say minimum based on the date. Okay. It's going to start on March 3rd. I'm doing this so we can kind of see how new rules um, affect the operation as we progress through the month of March. So I'm going to actually start January 1st with a 0 CFS. And then what did I say? 800 CFS will begin on March 3rd. Okay, and I'll tab off. And then I'm going to actually change this interpolation type to step. So starting March 3rd, we have a minimum of 800. I'm going to click apply and then also add rule to all zones. I'm going to add one more rule before we run our first simulation, and that's going to be a max release rule. So again, I'm going to select the zone and then right click add rule. I'm going to type or paste in the name of the rule. It's going to be a max of 1200 CFS applied to the controlled outlet release function rule. Okay, so I'll select maximum. Again, I'll just base this on the date. That's fine. And then this rule is going to start on March 5. So I'll type in 05 March and 1200 CFS. Now, before 1200 CFS, I'll just type in some large number here and then click apply. And again, let's go with the step. style interpolation, and apply. And let's go ahead and add rule to all zones. All right, apply. I think we're good with the reservoir editor for now. So let's create an alternative edit, and then I'll click on alternative new. I'll just call it alt one. Okay. Next, I'll step through these tabs to assign some alternative data. This first one will be run control, and I'll say 1 hour will be our time step. And I will just go with the existing default values here. Next is operations. I'll select operation set one because that's the only one we have. Look back is how we are basically the initial conditions of the alternative, how we want things to start during the look back period. The elevation I will set to the guide curve elevation. And then as for the release, I will start it at our constant 1000 CFS. Over in the time series tab, I need to select our inflow at CP1. And this is where we actually connect the time series dataset to our alternative by selecting DSS path, this button here in the bottom right. And then now I need to navigate to that dataset that I created of a constant 1000 CFS. When I click this set path name button, it goes ahead and populates this record over in the alternative, and we're good to go. The alternative does have additional tabs here for some other more advanced types of features, but we're not going to be dealing with that here in today's exercise. Save. All right, so let me close that. And let's see, I think we are ready to go to our simulation module. Oh, yep, got to save. Thank you. And simulation new, I'll just call it something generic like simulation one. And this will be for the month of March. So we'll go 1 March 2024. I'm going to start the simulation at the second hour of the month because ResSim requires the look back to be before the start period. So that'll be the first hour of the month. And then I will say the last hour of the month will be the end of the simulation. All right, I'll select our alternative one, click OK. Our network popped into place here. So we got that there. That's good. And I'll click compute. All right, close. I'm going to look at our results and right click plot. This is a plot of our results. It's pretty boring and predictable. What happened was the water surface elevation in this top plot starts at 1480 and remains at 1480 for the entire month. In the bottom plot, we see the flow, both the inflow and the outflow, and it's at a constant 1000 CFS. So if I highlight inflow, we see that in the black line. And then if I highlight outflow, it's again 1000 CFS. Okay, let's take a look at another plot, which may be a little more interesting, and that is right clicking and then click on plot operations. Okay, so what we see here is the top plot is a constant storage of about 28 or 29,000 acre feet. But what's interesting is this bottom plot here, which shows the flow as well as the release rule constraints. So let me go ahead and modify this plot real quick. Plot, select variables. I don't really need to see this top plot. It doesn't add a whole lot of instruction for this exercise. So I'm going to remove the entire plot region, actually. Can I do that? Apply. Okay, cool. So have removed that entire plot region. Now what we see here, let me zoom in on the first few days of the month. Okay, I've highlighted the minimum flow. So it starts at 0. On March 3rd, we introduced that minimum of 800 CFS. That represents this line here. The maximum release rule, which began on March 5th, it becomes active on our plot here and shows up to be 1200 CFS. And I think I can highlight that. We see that 1200 CFS. Now you might be wondering what's up with this, the first 4 days of the month. And why is it at 3640? Well, if you remember, our water surface elevation is at 1480, and based on the reservoir geometry, our controlled outlet can only release this 3600 and so on CFS at that elevation. But as you can see, it doesn't really play a role in our release because if I highlight the release from the reservoir, here's the release from the reservoir. Here I've highlighted it's in this bold green line and it's holding steady at 1000 CFS. So we knew that from the previous plot, but it's interesting to see how we have maximum constraints that are changing and minimum constraints that are changing based on our rules. All right, so this is my base case. What I want to do next is add a rule to say that the minimum release is 1400 CFS. So if I zoom in a little bit more, so if I introduce a new rule on, say, March 7th that says the minimum release is now 1400 CFS, well, that means the minimum is going to try to be up at this line here at 1400. However, we already have a higher release rule of maximum 1200. So that will change the flow to increase to 1200, and then it will be sandwiched between those two rules. Of course, the higher priority rule will govern, and that will be 1200. Let's give it a shot and see what that looks like using ResSim. All right, so I'm just going to go ahead and edit this alternative. I'm not going to go back to create a trial or the reservoir network module or anything. I'm going to go edit, run, and then I'm going to click on reservoirs, operations tab. And now I'm going to, let me expand this so I can see the whole name of the rule. I'll go ahead and right click, add new rule. I'm going to paste that rule in here. It's going to say minimum 1400 CFS, and it will be a release function. So what that looks like, it'll be based on the date. I'll start it at 0, and then on the 7th of March, it will be 1400 CFS. It is a minimum, and I'll click apply, and then, oh yeah, I got to go step. Cool. And then add rule to all zones. So there's that. Our zone tree rule here is how we adjust the priorities. This is an exercise on release rule prioritization, so that's probably important to mention. For each zone, we have a set of rules, which are nested in the little purple icon beneath that zone. For this exercise, I'm keeping both the zones here the same, just for simplicity's sake. And then the rules are evaluated in order from top to bottom. So the top rule is the top priority, and then the bottom rule is the lowest or the bottom priority. So what's happening is we will enforce whichever rule is on top first. So if there's any rule conflict in the rule stack, then the higher priority rule will govern. Yeah. Okay, so let's go ahead and see what happens. So here we have a rule that says the maximum release from the reservoir is 1200 CFS, but then below that, a lower priority rule says the minimum release should be 1400 CFS. But because 1200 is a higher priority, that will govern this conflict. And I believe that starting on March 7th, we will see flows of 1200. Apply, okay, and then okay. So let me go ahead and right click compute. All right, let's go ahead and plot. And this is not the plot I wanted to see. Let's go ahead and right click plot operations. And here is our plot. Below is the plot I want. Let me go ahead and actually do what I did before. Select the variables. Sorry, I should have saved the custom plot. I'll do that now. I'm going to remove the top region and then click OK. Then I'm going to come up to plot and say save plot type. And then I will select all watershed. And let's see. Okay, so I have a few saved already from previous exercises. I'm just going to call this rule prioritization. Okay. So what that did was now if I right click on the reservoir, because that applied to reservoirs, and then click user plots, I can just select rule prioritization and it gives me just that plot as I had saved it. Okay, so let me go ahead and zoom in on just the first 10 days or so here of March. Okay, so I'm zoomed in, and what I have here is the maximum release constraint that is showing here, where it begins on March 5th. That's highlighted, and then it continues until the end of the month, end of the year, really. And then if I highlight the minimum release rule, it's doing its animation here. It's going to be basically 0 for the first 2 days. And then on March 3rd, it's a minimum of 800 CFS. And then starting March 7th, it's actually trying to push up to 1400 CFS as the minimum. However, we already have that maximum release rule of 1200 that started on March 5th. So that's governing. There's really no wiggle room for ResSim to try to adjust the releases to achieve the guide curve elevation in the reservoir pool. It's this is basically a specified rule based on that conflict. There's a certain value, and that's 1200. So now I'm highlighting the release rule, which may not have been as easy to see based on all the other lines on the plot here. It starts at 1000, and then it was happy at 1000 until that March 7th date began, and the minimum of 1400 expected the flow to be higher than that. So now it's at 1200 CFS for the remainder of the simulation. I mean, 1400 cannot be achieved, but what ResSim is doing is it's trying to satisfy that rule as best as possible, even though it's impossible to satisfy. It's doing its best. Okay, so what I want to do in the last part of this exercise is modify the rule stack and change the rule prioritization. And what I'm going to do while looking at this plot, I'm just going to describe it here first, is increase the priority of that 1400 minimum release rule, and we'll set it to a higher priority than the maximum of 1200. So that's what we're doing. Go ahead and try to think about what the plot will look like and what the releases will be. I'm going to go right click and edit run, and we'll click reservoirs. We'll select the operations tab. It's already selected. Now to modify the release rules, you can just right click on the rule and say increase priority, and it moves up one. Or you could just right click and say move to top in case you had a bunch of rules and you wanted to just move one all the way to the top. The same way with decreasing the priority, you can right click and decrease priority or move to the bottom. So yeah, just keep in mind you'd have to do that for all your zones as well. So I'm going to increase the priority. So now what's going to happen is on March 3rd, we're going to have a minimum of 800 CFS rule begin. On March 5th, we'll have the same 1200 maximum CFS release rule begin. And then a couple of days later on March 7th, we'll have that minimum of 1400 CFS rule begin. But because this is a higher priority, I think what the flows are going to increase to 1400 CFS. All right, enough talk. Let's do it. Apply. Okay. And then okay. Compute. Close. And now let's right click. Let's click on user plots and then select our rule prioritization plot here. Okay, that's awesome. And sure enough, that's what happened. Let me zoom in. Okay, I've zoomed in on the plot here and see that the release starts at 1000 CFS and then it increases up to 1400 CFS based on that higher priority of a minimum 1400 CFS release rule governing and overriding the 1200 CFS maximum rule that starts here on March 5th. So anyway, there's a lot more examples I could provide for demonstrating release rule prioritization, but hopefully what I said in this exercise will get the basic understanding across and help you with your building zones and building rules here in ResSim.